Lesson 1, Pythagorean Theorem. So the Pythagorean Theorem is a theorem that we utilize when we're dealing with a right triangle. So what a right triangle is it's an angle that is 90 degrees. So that's when we can use the Pythagorean Theorem. And the way that it works is if we were to call this triangle A, B, and C, the side across, we always call angles capital letters, and the side across from this angle is going to be lowercase of that letter. So this would be called A, this would be called B, and across here would be called C. And the way that it works is if we take the side length of one of the legs, these are called a leg, and we add another leg and square it, we will get the hypotenuse squared. So a better way, we often think about it is a squared plus b squared equals c squared. It's probably the most common formula people remember. But if we think about it like this is a leg, this is a leg. It doesn't matter which one's which. This is called the hypotenuse because it is across from the right angle. The formula is leg squared plus leg squared equals the hypotenuse squared. And this is a better formula because it reminds us what each thing actually is. So let's utilize this. So find the missing value to one decimal place. So we're looking for this side right here, and because this is our right angle and it is across from it, this is our hypotenuse, so I'm going to call it h. So I'm going to do leg squared plus leg squared equals the hypotenuse squared. One of my legs is 5.2. Again, it doesn't matter which one's first. So I'm going to do 5.2 squared plus 3.8 squared, and I'm going to get h squared. If I add these two things together, make sure you square them first and then add them. It will not work if you add them then square it because of bed mass, but you will get 41.48. So we have 41.48 equals h squared. Now h isn't fully by itself yet. We have to get it by itself. So I'm going to square root each side to get rid of that square. And I will be left with 6.4 is equal to h. And a nice little check you can do is that the hypotenuse is always going to be your biggest side. Alright, example 3. This one's a little bit different. We have the hypotenuse squared. Not squared, we're going to square it. We have a leg. We are looking for another leg, so we are looking for L. So we have leg squared plus leg squared equals h squared. It doesn't matter which leg you make 6.9. So we have 6.9 squared plus L squared equals 12.8 squared. Now to isolate the L, we're going to subtract this 6.9 squared to the other side. And that will cancel. So we have L squared equals 12.8 squared subtract 6.9 squared. When I type this into my calculator, how about you pause it and try typing that in? The number that you should have gotten is 116.23. To get it by itself, we have the last step, which is square rooting it. So the length of the last leg is 10.8. Alright, next example. Determine if a triangle will be a right triangle. So first of all, we're going to say that the biggest side is going to be equal to h because the hypotenuse is the longest side. So we're going to just plug this in and see if it works. So we have 15 squared plus 8 squared is equal to 17 squared. And now to prove that it's a right triangle, if I type this in, the Pythagorean theorem will work. If it's not a right triangle, then the Pythagorean theorem will not work. So we're going to type the left side in, write the number down, type the right side in, put the number down, and see if it's the same. So pause the video and do that. you should have got 289 is equal to 289, which is true. Therefore, so 3 circles, therefore it's a right triangle. This is also a special triangle because there's no decimals on all of them. It is called a Pythagorean triple. There are special types of triangles because they're all whole numbers. Remember this word because every year in all of my math classes it comes up, every single one of them. And I will ask, does anyone know what this special word is? And no one will remember, but maybe this time you will. Alright, example 5, we've got a word problem. A ladder that is 5.2 meters long rests against the vertical wall of a house. Okay, house, ladder. It's apparently going to the roof. 5.2 meters long. The bottom of the ladder rests on level ground, so we're going to make sure that assumes that it makes a right angle, and it's 1.6 meters from the wall. How high up the wall is the ladder reaching? So we are looking for the hypotenuse. Just kidding. We have the hypotenuse, we have the leg, we are looking for a remaining leg. So we have leg squared plus leg squared equals hypotenuse squared. So we have 1.6 squared plus x squared equals 5.2 squared. We're going to subtract the 1.6 squared to the other side. So we have x squared equals 5.2 squared, subtract 1.6 squared. I want you to pause the video and try typing that into your calculator. You should get that x squared is equal to 24.48. Square root that number, and that answer should be 4.95 meters. So it's going 4.95 meters up the wall. Alright, last example. A vertical tree is to be supported by a wire. Okay, a tree is getting supported by a wire. Interesting. Tree, wire. Wow, it's like I'm there. Okay. The wire itself is 7.25 meters long. It's attached to the tree 5.65 meters above the ground. How far from the bottom of the tree will it be? So we're going to have the right angle made with the tree and the ground. So we have the hypotenuse and a leg. We are looking for the remaining leg. So we have leg squared, plus leg squared equals hypotenuse squared. So we have 5.65 squared plus leg squared equals 7.25 squared. To get the hypotenuse by itself, we will subtract 5.65 squared from both sides. So we have leg squared is equal to 7.25 squared, subtract 5.6. Okay, first of all, it's a 4, and I've been writing 5 the entire time. It's a 4. So 5.64 squared. Pause the video, type this into your calculator. You should have got that L squared is equal to 20.7529. Square root that answer. And the length from the bottom of the tree to where the wire that you're attaching for some reason to a tree is 4.56 meters. And that's a Pythagorean theorem, and you will use it forevermore, except possibly in real life. Thank you for coming to my TED Talk.